Here we have a question from 2019, question 3, on rotation and translation of points. And these questions are really just to make sure you've understood the very basic aspects of rotation and translation and homogeneous transformations. And they're, if you like, a fairly easy sort of a source of points for you in the exam. So here we want to ask, well, here we're asked to rotate point P1 around the x-axis by 30 degrees and then translate it by 1 in the x, 2 in the y and 3 in the z, generating a new point, which is going to be P2. So first of all, it's asking us to write down the rotation matrix, which achieves a rotation of 30 degrees about the x-axis. And what you have to do is just look up in the list of formula normally that you get provided with, and you'll see that the x-axis rotation matrix is given as follows. We can tell that this is the x-axis one since it's not going to affect the x components. As you can see, it's got a 1 here. This multiplies against the x. We're doing it for 30 degrees, and 30 degrees again is a value that you might be familiar with the cosine and sine of. If not, just use a calculator. But cosine of 30 is going to be 0.8660. Sine of 30 is half. And if we then substitute those values in immediately, we make life a little bit simpler. And that's what we've done. We've put the cosine goes in as 0.866, 0.866, and minus a half and a half, respectively. Then we're asked to just build the homogeneous transformation matrix, which will achieve this rotation with obviously a homogeneous data point. So the homogeneous data point's got a 1 appended at the end of the column vector. We've got the 3x3 rotation matrix component up here. And because this is just purely a rotation, there's no translation component. So this 0, 0, 0 here represents no translation at all in this particular example. And it gives another homogeneous point back. So we substitute in the values, or just directly substituting in the 3x3 matrix you had before, we end up with the formula which to give the evaluation of the rotation matrix. Obviously I've done this in MATLAB just to reduce the chances of me actually typing something in wrong. Right, now it's asking us for the translation matrix in homogeneous form that will achieve a 1 displacement in x, 2 in y and 3 in z. Right, so the form of the translation matrix in homogeneous form is going to be the rotational part here, a 3x3, is just going to be the identity matrix because it's not going to actually rotate anything at all. Then we have the tx, the ty and tz components of the translation. And of course in our case we've got tx equals 1, ty equals 2, and tz equals 3. So we plug those values in and we have a 1, 2, 3, 1, 2, 3, that's right. That was quite a simple thing to do. And then we can build the single homogeneous transformation matrix that realizes the rotation followed by a translation. And we can either do that by multiplying them out, right? So first multiply, well, on the right hand side we have rotation and translation after it. In order to multiply those out, you could just do multiplication, or we should, you can bear in mind that the homogeneous transformation matrix does things in that order. It does first of all the rotation and then the translation, which means you could directly type in a rotation and a translation into a homogeneous transformation matrix, and it will do things in the order that we're actually requested. If it asked you to do it the other way round, rotation, a translation and then rotation, then you'd actually have to do the multiplication the other way round. So now it's giving us a point that it wants to calculate transformed by the homogeneous matrix that we've just come up with. So the point is 5, 4, 3. The homogeneous point, basically we stick a 1 on the end. And to transform this, we multiply the point on the left-hand side by the transformation matrix, and we'll end up with a value, in this particular case, of 6, 3.96 and a bit, 7.5 and something, and 1.